AB calculus lesson on linearization. Okay, guys, so we are going to study linearization. Let's take a look at one of the more common function, ln of x. So let us say we want to estimate its shape. But before we begin, let's kind of look at this right here, guys, okay? There only should be one f of x equal to ln of x. Just draw some random like what looks like a log function, and be sure to indicate the a and f of a like this. And we're going to focus on this area, okay, guys? And that's going to be over here. And what you see here is that I kind of exaggerated the curve a little bit. And then we have a, f of a, which is x naught, y naught. We can write that as a comma f of a. And this slope over here is obviously the m slope is f prime of a, right? And instead of calling this y is equal to mx plus b, let's call this ln of x. It's a line x, right? Near a. So this would be near x equal to a. All right, so we're going to use that to estimate the curve, right? And then knowing what we already know, guys, right? Look at that. We know that it's f of f minus y naught, which is f of a, slope times x minus x naught, which is a. So that's basically a tangent line, isn't it? Let's solve for y. Move that to the other side. And the ln of x is essentially that right there. Okie dokie. All right, guys. So do me a huge favor and write these three things down. So when do we use these things? Well, if a function is complicated or is in a or if a variable is in a complicated equation, then sometimes you want to use a simplified version of the function. Or maybe it is possible to evaluate f of a, but difficult to evaluate f of x elsewhere. And it's also possible to use tangent line. We just did that. A curve at x equal to a. And let's call it L of x instead of f of x. Okay. All right, guys. Using the ln of x, let us do the linearization. We are going to go up close and personal equal to x equal to a, right? Given this, and we're going to estimate the value at 2.03. So instead of doing at 2.03, we're going to go with the easy number, like 2. And that's exactly what we're going to do, okay? All right, guys. And then later on, we're going to determine for what value of x is the linearization correct to within 0.05. Just remember that, guys, that's y value, okay? So let's come back to C in a second. The first thing we're going to do as over here is L of y is y naught plus m times x minus x naught. The y naught goes in the back, right? So essentially that's what that is. So that's x naught, a is 2. Plug that into f of 2 gives you y naught. And then to find the slope, you take the derivative of the function, which is 1 over x, and then plug in at x equal to 2 gives you a slope at x equal to 2 over here. And we plug everything here, the function is approximately this, right? Near x equal to 2. That's what we're saying. So if we want to estimate the value, right, 2.03, we plug that value in. That's very doable. Like in the old days, we'll have a table of values for ln of 2. I wasn't allowed to use a calculator. But trying to do this without strictly using a calculator, the techniques and whatnot, it's really it really builds our skill sets, right? And when you evaluate that, that is equal to 7.08, 0.708. Okay. All right, guys. So going back to third question. So you could be asking yourself, okay, how good is this linearization? How far can we go, right? So you might be asking that question. Obviously, if you extend this forever, that gap and this curve, there's too much of a gap. Here, there's less of a gap. So what is acceptable to you, right? And the question is saying 0.05, that's what's acceptable to us. And that is how you express it right here. Okay, the difference between the linear capital L of x minus f of x absolute value has to be less than or equal to 0.05. Okay, I'll prefer that to be the first step for the C. I'll get a big smiley face if you do that. Okay, so what does that really mean? Okay, so I drew a quick picture here, guys. Okay, the one in the middle right here, that is the f of x. The one above, that's 0.05 above the f of x. The one below is the 0.05 below the f of x. And this linearization over here, guys, will look something like this. Because of the curvature of the function, the linearization will intersect with f of x plus 0.05, but it will not intersect with the bottom one. But even if the curve goes around and ultimately hits it, we don't really care at that point, right? We want to know how far we could go above and below acceptably in what x range, like near the x equal to 2. So that's what we care about, the intersection near x equal to 2, right? So that's the overall idea, okay? So where is ln of x, L of x acceptable if the tolerance is 0.05, like in what values of x, right? And that's what we're interested in. So when you get rid of the absolute value, this is what we get, right? And adding f of x to both sides, that's what we get. But this right here, question is, there's no intersection here, guys. I know that L of x will always be bigger than that, but that's not the point here. Does it intersect over here at all? No. So we don't have to worry about it. It will always be larger. But we have to look at the upper limit. There is an intersection right here and here. So I like to see the intersection, right? But how do you find the intersection? Right here. GC, meaning graphing calculator. All right, guys? Yeah, that is it. You know what? I typed it up on my TI. Let me share that with you. Let me change the screen really quickly. Where is it? There you go. All right, guys. So y is equal to this. This is the linearization, y1 that's in blue. Red is the actual function that we're dealing with. And then two blacks will be above and below by 0.05. If I trace it, it took me a little while to sort of figure out the window to make it fit. What we have to do is find the intersection of the blue and the upper black. Do you see that? So what I'm going to do is to avoid any confusion, I'm going to get rid of let me just click down so I don't see it. So it'll make things easier for me, okay? There. And let's get rid of the red as well, okay? So we're looking for the intersection of these two. Is that right? Right. And how do I do that? Second, calc. We're looking for the intersect number 5. 5, inter. And then what's the second curve? It's the black one. And guess, okay, you don't really have to do it. You'll choose one or the other. I'm just clicking all the way across. There you go. You don't have to be right on it, but somewhere close. Right there. It gives you 2.7008, right? And to find the next one, you could do it again. Second calc, which is number 5. And then first curve, inter, second curve, because there's only 2 of them, right? So it really doesn't matter. And what we could do actually is that this is 1, isn't it? Right. So that's about what? I don't know. 0.7? Right? I don't know. So you could actually either scroll left or, oh, I'm sorry, that's 2.5 right here. That's 2. Let's try 1.5. You could actually type it in. All right, just guess it. And yep, it gives you the exact value, 1.43238. Okie dokie. All right, guys. So let's get back to the iPad. And we're back. Okay. So that's what that is. Okay. Now, so what we do need to write it to complete sentence. So linearization of L of x is within 0.05 when this is true. But we generally like to put this right here, guys, don't we? All right. So in an interval notation, you could say X is in. So that means it's a member of or is in. So I think in this case, is in is better. All right. So there it is. Why don't you take a little bit of time and try the example number two. But here are the answers, guys. Okay, just so that you're not spinning your wheels. And good luck. Actually, pause the video. I'll go over it in about a few seconds. Okay, pause the video. All right, guys. Have you finished? Or did you give at least did you give an honest try? Okay. So the answer that I got in this case is this. This is the workout that I have. Okay, let me make that a little tiny bit smaller so you could see everything. You know what? Maybe I could just move this to the left hand side. Hmm, I don't know, like that, so you could see better. There you go. Now let's zoom in the picture that we have. Now in tangent, the graph actually looks like this, but we only care about near the pi over 4. So just for sake of simplicity, just draw this part, right? And that's the one above and below. And we care about near the pi over 4. So because of the curvature of the curve, it will intersect with the bottom two, right? So we could ignore the one on the top, right? So just keep that in mind, right? And that's why we set that equal to each other, right? And then when you did, that was the answer. Okie dokie, guys. All right. All right, guys. That wraps up the linearization. All right. So have a good night.